If we manage to survive,
we will.
We don't get hit by an asteroid.
It's going to be okay.
We hit an asteroid with a satellite like 2 weeks ago.
Don't listen to him. We're going to be fine. Anyway.
Should we do a really quick recap of Matt Damon and then get to the end?
I forgot. Well, and my favorite scene, though, the docking scene where it's spinning.
Oh my gosh.
So in the time that you could watch this podcast, you could watch about 2/3 of the movie.
Yeah.
So,
go watch the movie.
But the spinning, the thing about space is that all movement is relative, right? And so the space station, Matt Damon.
Okay, so 30 seconds in on, they're like, okay, planet with giant waves, can't live there. Let's go find Matt Damon. So they go to
Dr. Man.
Dr. Man. They're not being subtle at all
right.
with
mankind.
this. And they go and they find Dr. Man, who's the best of us, and he's been sleeping for a long time in the pea water. Matt Damon. And he wakes up and he's like, yeah, this planet's totally great, even though it's got frozen clouds of methane.
Yeah.
And the air is Windex. And
yes, ammonia air. Yes.
And they're like, yeah, just follow me into this hole and we'll be fine. And Matthew McConaughey's going in there and he's like, follow this hole. And it turns out that he's gone evil.
Well, he's just cowardly.
He's just become cowardly. He's a man.
He wants to survive.
Susceptible to the survival instinct of a man because we're not subtle at all in this movie.
Dr. Man.
Dr. Man. The other guy who might be right is his name is Wolf.
Oh, that's right.
That's right. Anyway, so Matt Damon tries to throw Matthew McConaughey in a pit. He's breathing ammonia. That's not pleasant.
Oh, no.
And the next thing. And then he gets on. He's trying to get on this planet because he wants to get on. He's been on this planet by himself for 20 years.
Yeah.
And they actually about 35 years at this point, probably by his perspective, he's been alone. He's been asleep for a lot of it.
But his
10
planet,
years plus 23 years.
But his planet is also experiencing some time dilation.
That's true, but probably not nearly as much.
Not as much as Miller's planet.
Yeah. Anyway, it's been a long time.
Yeah.
So he steals one of their ships, blows up Rom. That's the name of the guy who got really old.
Yes.
And goes up there and he's trying to dock with the station.
Yes.
He doesn't do it properly and he ends up
overpressurizing
it and sending the space station that they're on into a spin at 67 rotations a minute.
Yeah.
Which is many, many G's.
That scene, the number of times that I've watched just that scene on YouTube is kind of sad that I have watched it so many times. But so the station's rotating and Anne Hathaway and Matthew McConaughey, they have to get with the station because it's got everything that they need to live, as well as all these embryos of these humans that if they're not able to rescue the people on Earth.
Plan B.
Yeah, and so anyway, they rotate along with the station as it's rotating. I just love it. Anyway, the Tesseract. We got to finish.
Okay,
it.
So they get into the thing. It's a 3-hour-long movie. So they get into Matthew McConaughey's it up, and it's awesome.
Yes.
And they get on.
Yeah.
That's music.
Yeah.
And they get back on there, and they're being sucked into the gravity of Gargantuan.
Yeah.
And so Matthew McConaughey is way better at math than any human I've ever seen. Calculates that he can use the accelerate like they've done with Mars by using the gravity of the black hole to shoot them at the planet they want.
Mass.
But they're going to have to lose some mass because Newton's laws. And so they do that, and he ends up ejecting himself from it to save Brand and humanity.
Yes.
And he falls into the black hole. Now, in reality, if you were to fall in a black hole,
spaghettification,
you would die a lot.
Very fast.
As you were falling into it, the gravitational forces between your feet and your head would be so different that it would start ripping you apart at the molecular level.
Yeah, no, like you'd be a string of atoms.
pulled slowly into this.
Your molecules get pulled.
And
apart.
while your perspective of this would be happening at this normal speed, if you somehow were alive, from the outside force, you would sit on the outside, on the event horizon of the wormhole forever, because time stands still there. So he falls in, and then some weird stuff happens, and he's in this room that seems to
go on forever in every direction.
And what it is he's in a tesseract. And so a tesseract, this is my personal
cube.
favorite part of the movie.
An hour and 30 minutes into our podcast.
Oh my God, I love this part. So he falls into it, and so a tesseract is a 4-dimensional cube. And in this particular tesseract, that would be a 4th dimension of time. So imagine, I would say that we are all 4-dimensional beings.
Yeah.
Because we are currently traveling
We're moving
through
through time.
We just don't have the ability to
move any other way
control
direction
with
in
that.
it. Yeah.
Probably. And cornbread.
Not cornbread.
Not corn.
It's lemon cake, but it's the color of cornbread, and I couldn't find actual cornbread. So, way to go, Croshaw.
Good job. Anyway, so I fall into it, and it's just a series of rooms, over and over and over and over and over again.
Well, the same room.
But he doesn't
different
know.
time.
But he doesn't know this at first.
Yes.
And this is why it's my favorite scene.
Okay.
Because I've tried to visualize a tesseract since I learned it was a thing when I read. What book is it? Oh man, what's the name of it? Anyway, there's a tesseract in the book. Oprah starred in the movie version of this 3 years ago.
What? Oh, Golden Compass? No. No. Wrinkle in Time.
Wrinkle in Time.
There it
Wrinkle
is.
in Time. I read Wrinkle in Time when I was 10 years old.
Yeah.
And it talked about a tesseract and it blew my mind.
Yep.
And I've been trying to visualize this for 20 years.
Yeah.
Or no, more than 20 years. And they go in there, and this is a visual representation of the tesseract. It is the same area of space in every moment of time.
Yep.
Like, imagine that you had a loaf of bread, and each slice is, and that slice
It's the same slice.
It's this,
at a different time.
yeah. So each slice, the bread itself is the lifetime of that thing or
the
that
bread.
room or that area.
Yeah, uh-huh.
But each slice is a different time, and within that slice is the entirety of the other 3 dimensions that we are aware of.
Yeah.
And that breaks my brain. But he's in here, and he can go to each individual moment that has ever existed, and he's in Murph's room.
Yeah.
And he can go to any time where that space has existed.
Right. And what's interesting though at this point is that like he didn't do this.
Yeah.
Right. And he has this revelation that he's like, they are us
In the future.
and Tars
making
is
the
like,
past happen the way it has to.
yeah, and Tars is like, humans couldn't do this, Coop, and he's like,
Not
yeah,
yet.
not yet, right? We will do this, and this is how we're saving humanity, is we're going back in the past to make this happen.
Humans invented writing
Yeah.
5,000 years ago.
Yeah.
That is a blink of
Of
an
time.
eye.
Imagine what we will be in 10,000 years.
If
in
we manage to
100,000
survive,
years. We will. I'm optimistic.
if we manage to survive,
We will. It's gonna
we
be
don't
okay.
get hit by an asteroid.
It's gonna
We
be
did
okay.
We hit an asteroid with a satellite like 2 weeks ago.
Don't listen to him. We're gonna be fine. Anyway,
But if we do,
don't panic. Don't panic.
what the human brain can create,
Oh yeah.
we don't even.
Oh yeah.
The things that exist today that are normal
We're not gonna
were
be able to-
science fiction when I was
Oh,
a
yeah.
kid.
We can't fathom what technology is going to look like in 10 years. Imagine 10,000. Imagine 10 million.
I remember getting a flip phone and thinking I was in Star Trek.
Oh my gosh. 16 years old. I got my first phone. I was so pumped.
So much older than
I go and text Chelsea Brinkerhoff.
Wait,
Shout out to everybody that knows that name because anyway,
wait, where did you grow up?
I grew up in Springville.
I
Mapleton.
knew Brinkerhoffs. I knew a lot of Brinkerhoffs.
Yeah, I'd say it's a relatively common name. Anyway, yeah, but the technology that we're going to have to building a Tesseract seems impossible to us now. Mm-hmm. But it may not be in the future. Mm-hmm. And that's what I love about it.
So he's in here and he realizes that he's the ghost and he can leave a message.
Yep.
And what he ends up doing, I don't know how,
Well, using the gravity.
But he manipulates the gravity.
Through the Tesseract, which
Through the
is
Tesseract,
a whole
which is a
different
whole
thing.
different thing. But I was thinking about this a lot last night as I was watching this movie for the 50th time.
Right.
And I was thinking to myself, okay, if I were to transmit something from inside of a black hole, the only force I can think of that would have a choice, that have a chance, would be gravity.
Yeah, because you can't do light.
I can't do light. And everything we think of is light.
Well,
I absolutely can't do the strong force. I can't do the weak force. I don't know how to manipulate the Higgs field. But
quantum entanglement. But we don't really know how that works. But gravity.
But gravity does.
Yeah. Well, gravity, though, travels through space-time.
Because we don't know how gravity actually works.
Right.
We know, we theorize, and all of the information backs up the idea that time or space-time is manipulated and warped by the presence of mass, and that warping is gravity. But how?
And energy.
And energy. Well, it's the same thing.
Well,
E equals mc squared.
Yeah.
But if you look up how that works, that is very theoretical. Is there a thing such as the graviton? We don't know.
Maybe.
So for every other thing, every other force, there is a particle, a messenger particle. You have photons for the electromagnetic force. You have the W and Z bosons for the weak force. You have gluons for the strong force. We don't know how gravity is transmitted. We know that it transmits at the speed of light. Mm-hmm. But how the crap
does it go?
Is a black hole from the inside transmitting the information of the gravity within the thing, the singularity, outside of it, if the information can't go faster than the speed of light? And I don't, and a part of it's just like, I do not understand at all how gravity works at quantum level, and nobody does.
Right.
But if I were to, and I could somehow
what about like
manipulate the gravity within
what about like
a black
quantum
hole?
entanglement with gravity? What if he's manipulating something gravitationally that is entangled with something in her room?
I don't know, but it would make like that makes sense from a quantum.
And it makes sense in terms of instantaneous, right? It would be instantaneous.
And quantum, for those of you who have never heard of quantum entanglement, the basic idea is that if you have two particles that are created at the same time, they are linked quantumly. Yep. And if something happens to this thing over here, like you measure it over here,
or like rotate,
and you know that its rotation is left-handed, you automatically know that this is right-handed over here.
Right.
And what's weird with the way the quantum mechanics works is things are not particles until they are observed.
Right.
That means
mostly they're waves.
They're waves
until
they're observed, and then they collapse themselves to become singularity or singular point, probably.
Particle.
Yeah.
Yes.
But if I measure this over here, this wave over here collapses as well.
Right.
And that means that this thing over here and that thing over here communicated, and it doesn't happen at the speed of light, it happens instantaneously.
There's no delay.
And that breaks every law of physics that I understand.
Yeah.
But it happens. We've measured it. We've watched it happen. We have transported protons from one place to another using this.
Yeah. Well, and so it might be an entanglement thing. I mean, who knows, right? But they get a little cheesy here with the whole thing with like love.
Yeah.
Right? Like love is the only thing that can propagate the whole universe or whatever they talk about.
Chemical reaction inside your brain. That's why it feels instantaneous.
Right. Yeah. Right. But it's
not to be a non-romantic.
Well, but I mean, there's facts, right? But okay. So, hour and a half later, incredible the way that they present this idea of gravitational lensing, the idea of time dilation. And, cut to the end of the movie, he gets picked up just outside of where the black hole was.
Yeah, he falls out of the black hole.
Somehow.
Through
the Tesseract, which we don't see Tars in the Tesseract, but Tars is somewhere in the Tesseract.
So yeah, Tars falls in before. Tars could have been there for the eternity of the universe.
Right.
Already.
Oh my gosh. Yeah. Anyway, Anyway, so they say that. Do you remember exactly how old they say he is when they pick him up?
120.
No, it's older than that. Don't they say he's like 200 something?
No. He is.
I don't remember.
He's
you're
124.
no spring chicken anymore.
124 is what his numbers in my head. I'm 80% positive.
And then he
that's
assumes
about right.
that Cooper Station is named after him,
Yeah.
which is an O'Neill cylinder, which I absolutely love.
Think the
2001: Space Odyssey.
Oh, I was gonna
rotational.
I was gonna say a Halo.
Oh yeah,
the Halo thing.
Just smaller.
In Halo.
Just a little bit smaller, because Halo's like really big. It's
Yeah,
like
Halos are
planet
like the size of what are they called?
They're like planet sized, right?
I think so.
But the O'Neill
As
cylinder.
a Dyson sphere. I think some of them are supposed to be like the size of a Dyson sphere.
Okay, but anyway, the O'Neill cylinder, and you see the kids playing baseball, and the kid hits a home run, and it goes up, and then because of the rotation, it ends up hitting, like it goes past the middle of the cylinder, and then continues upward like it's falling.
I need to watch that scene in slow-mo to see if it actually follows the trajectory, because if you were to do that, the baseball would look like it's curving.
Yeah, it would do
because
this like
it's going here, and the difference. So if you go from here to here, the middle of the cylinder is spinning slower than
has
the angular velocity is smaller than here, and so it goes through, force. And since it's going this way and that way, it goes.
Yeah, exactly. And then it hits somebody's skylight, and all the kids cheer. Anyway, and then he goes in and he sees his house that's been preserved.
Yeah.
And we cut to one of the interviews that's from the beginning of the movie, which we thought was just some
random
old lady.
But it's Murph.
It's Murph, and that was a great reveal. And then he meets Murph, and she's now in her 80s or 90s.
She's going to be about, if he's 124. And she hasn't experienced time dilation.
He's like
and
34 when he leaves.
She's 25 years younger than him or something.
Yeah.
That puts her at 100 years old.
Yeah.
And she's been in cryostasis for 2 years.
Right.
To go get him.
Yeah, to see her dad.
Yeah.
Right? And this moment...
I cannot make it through this part of the movie
that moment, I'm telling you, man, in 2014, sitting in an IMAX theater, just bawling my eyes out.
I watched it last night, and I've watched that scene a lot of times.
Oh yeah,
and
I cry every time.
I cried during, and I was like,
oh my God.
I'm in my house by myself in the dark on the couch watching this on my laptop, eating pasta, and crying like a baby.
Yeah, and but it's. I love how.
You told him I like farming. It was me, Murph. How was your ghost?
I know. People didn't believe me. They thought that I was doing it all myself. But I knew who it was. Nobody believed me. But I knew you'd come back.
How?
Because my dad promised me.
I'm here now, Murph. I'm here.
No. No parent should have to watch their own child die. It's here for me now. You go.
Where?
Brand.
I love how it's all tied together, and then he goes to find Brand, right? At their new home that they're all headed to, and he steals a Ranger, you know. And
I love that part.
Yeah, and
guy comes in, he's like, "Oh my gosh,
there's a missing spacecraft."
spaceship."
And you know, and then the movie ends. And I'll tell you, like, really, in terms of science fiction, I don't think that it gets better than Interstellar.
I think Interstellar. I love science fiction, and I love science fiction of the cheesy sort, of the unrealistic sort, and I love science fiction of the super realistic sort.
Yes.
Interstellar is maybe the best sci-fi movie
Hard
I
sci-fi,
have
yeah.
ever watched, and that coming from a person who considers the Alien the best horror movie ever made,
Right.
and by a lot.
Yeah.
That is incredibly high praise.
I think
It gets me on every level. The only part I don't like of the entire movie is the Anne Hathaway scene where she talks about how love
Yes. Okay.
is
yes.
that thing, because it's cheesy and no one talks that way.
Yeah. Exactly. Well, and especially not a scientist.
Especially a scientist who's smart enough to figure out how to, like, get into space and travel through a wormhole to other planets so you can like save the
You got
people.
a PhD in theoretical physics.
Anyway, there was one more thing I wanted to say and I forgot to say it.
Okay.
So he's in the black hole
Yes.
and he uses binary and Morse code to
On the
tell
watch
her
that he left.
what the data is of the singularity of the inside the black hole. So he uses gravity in order to get the information out of a black hole. Now, one of the problems with the universe and black holes is the destruction of information. The preservation
black
of information is key to the universe working the way we think it does.
Except for black holes.
Except for black holes.
Right.
And even with Hawking radiation, it comes out and it's nonsense. Even
It
if
doesn't
a
have
part, it has no
information.
meaning, so there's no information, so it destroys info. But if you could get it out
Yeah.
with gravity, if gravity somehow transmits that information.
No, but it's love, Kevin.
No,
It's love.
love is a chemical reaction inside your brain, and it's a great chemical reaction that keeps the human race going.
I agree.
This is not me hating on that at all. It's just we're genetically designed to feel that. And it's happening in our brains. You
Yes.
can measure it. But gravity is already being transmitted from a black hole.
Right.
And that is by itself weird. And if we
Right.
ever figure out how gravity actually works, maybe we figure out how that works. And if we unlock the secrets of transmitting information over periods of space and time faster than the speed of light or through things like that, it would change our very understanding of the universe in a way that hasn't been since the idea that the Earth,
Yeah. Well, and
the
this is,
heliocentric universe,
well, and this is how they don't really
the
go
invention
into,
of science.
Right. Well, and they don't show this, but that O'Neill cylinder, Cooper Station, is lifted straight off of Earth with no propulsion. Right. They just completely brush over this. That like they reverse gravity. Essentially.
They figured out how to change the gravitational constant or something.
Right.
And move
Or like make
Parts-
it negative. So what
Using
the entire
gravity-
station just completely lifts off, no propulsion,
Which-
and no force. They're using gravity as the propulsion, which
is oddly similar to dark energy,
Yes,
which we don't know what that is either.
Right. Well, yes. Which anyway, masterpiece. Honestly, one of my top 3 films of all time.
Mm-hmm.
I would say that Nolan and the whole team that worked on this, but especially Kip Thorne and the science that he contributed to this, really is deserving of just so much credit.
I think it's an example of what the best scientists should do.
Yeah, and how we as educators and science educators especially, how we can use art to inspire and art to tell these stories through science. That science is not just this cold, unfeeling thing. And I think that that's kind of just the theme of this whole podcast, is that science makes for amazing stories. And we're able to tell stories that really make us ponder and touch us on a human level. And I know like being all cheesy and mushy and stuff, but touching us on a human level of like feeling these feelings of inspiration and just awe through science, I think is extremely important.
I will say that I think the power of science to inspire awe in people should never be underestimated.
Yeah.
The amount of people in 10 years who, as kids, will have seen a movie like Interstellar, who got into physics
Yeah.
because something about that caught them.
Yeah.
That number is going to be absurd. Like, I think of the number of people who went into science because of cool things they saw on Star Trek.
Yeah.
Or the amount of things that were invented because they were on Star Trek.
Right.
The amount of people who ended up in science because they watched Bill Nye and the Science Guy as a kid.
Yeah. Science communication.
Science
It changes the world.
Science communication is so important that I wish all scientists would take creative writing classes.
and that's the whole purpose of this podcast, right? We have
Yeah.
a science educator and a literature English educator, and being able to convey ideas about science, because scientists are notoriously bad at communicating. Like,
And science textbooks are so hard to
or
read.
well, even worse, science papers.
Oh, God.
They're so dry. They're just full of just really obscure words and phrases, and you have to cut through all the bullcrap. But-
Even if you know what they're saying.
Oh yeah, like reading
It's
this paper
still, like-
about Interstellar. Yeah.
Yeah.
So I think that the ability to communicate things that are difficult and complex and make you think in a way like Interstellar does, I think can really change the world.
Agreed. And with that, I'm going to say we're probably almost out of battery power, both computer-wise, camera-wise, and human-wise.
Yes. Thanks for watching.
Thank you for watching.
Listening.
Go watch Interstellar. Read some sci-fi.
Did we have an outro last time, like a catchphrase? I don't remember. Be smart and enjoy smart things.
Dun, 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 dun.